Hey everybody, I'm going to split up the next couple of topics in two different videos. The first one's going to talk about horizontal projection. So that is when like a ball would be falling off of a tabletop, or if you were to throw a ball off of a mountain or something like that. Okay, so horizontal projection, something where you start kind of high up, okay, and then throw the ball or some object off of it. That's horizontal projection. All right, so let's look at a practice problem because the math on this is somewhat complicated. All right, we have to deal with both the x direction of things, so the horizontal motion, x direction, and we have to deal with vertical motion too, which is y direction. Remember, projectile motion is the combination of both the x and the y. But we have to look at them independently to get the right information in place for our problems. So let's look at one and work it through fairly slowly. Okay, so a man proudly stands atop Mount Giraffemore. So here he is. There's our mountain. Here's our guy. Okay, he throws a ball horizontally off of the mountain with a velocity of 4 meters per second. If Mount Giraffemore is 70 meters tall, how far will the ball land from its majestic base? So 70 meters is the height. He throws the ball at 40 meters per second in the x direction, and this is in the y direction, okay? And it wants to know the distance in the x direction. Now, to help us out, we're going to create a chart for each one of these problems. The reason being is that we have information in both the x and the y direction, all right? So for all of these problems, I highly recommend A, you draw a picture, and B, you draw this chart. VI, VF, A, D, and T. Those are the variables that we've been working with this entire time, right? All right, so let's put that. Separate them like so. Now, a couple of tricks. In the X slot, or in the X column, we are never going to have a VF or an A, okay? For projectile motion problems only, you will always use velocity equals distance over time. And this is in the X direction. Okay? So we will always use the average velocity equation for the X column, the X direction. In the Y direction, though, we do have acceleration due to gravity, so we need to make sure we always are keeping up with what information we put there. Okay? So let's plug in the information that we have as we can. We know we have a velocity of 4 meters per second from it being thrown horizontally, and horizontally means x direction, so the 4 goes here. We want to know distance in the x direction because it says how far will the ball land from its majestic base. Time is the only thing that connects x and y. So time is going to be the same number for both x direction and y direction. So that's a good thing to know, all right? For y, we know that the guy is standing up on top of the mountain and he throws it off. And prior to him throwing it off, it's at a velocity of 0 in the y direction. Because remember, he throws it out in the x direction at 4 meters per second. So initial velocity for our guy in the y direction is going to be 0. Okay? We also know acceleration in this case is 9.8, positive 9.8, because he's throwing it down towards the center of the Earth. We also know distance of the y-axis is 70 meters. Okay? So with the information given, I give you an initial velocity, an acceleration, and a distance, and I want to find time, because if I find time for y, that will be the time for x, and I'll be able to do velocity as distance over time to find the distance in the x direction. So for this is a multi-step problem. We have to find t for y first, then plug that answer in to find d in the x direction. So this formula, again, it's our fun formula, d equals VIT plus 1/2 AT squared. Distance is 70. VI is 0. Time we don't know, plus 1/2 9.8 t squared. So that can get reduced down 4.9 t squared. And that is going to be 70 divided by 4.9 is 14.3 t squared. To get rid of the squared in the t, we take the square root of it. So we take the square root of 14.3, and that gives us 3.8 seconds. Okay? Remember, time is the same in both the x and the y direction. So now I can use this time that I just calculated and put it into the average velocity equation. So v equals d over t. V was 4 meters. D is what we want, and t is 3.8. So d equals 4 times 3.8, and that is going to be 4 times 3.8 is 15.2 meters. Okay, so the distance that the ball was thrown out in the x direction is 15.2 meters. Now hopefully you're able to follow along with that. What I would like you to do is, if it was confusing, is go back to the beginning of this video and watch it again. Your key components are: make a drawing, make a chart, make sure you X out the VF and the acceleration in the X spot, and make sure you know that time is always going to be the same for both the X and the Y directions. Okay? Watch this video a couple of times if you need to, otherwise please attempt the practice problems. Now the next video that I'll shoot is all about parabolic motion. That's where we shoot something from the ground, it goes up and comes back down. Okay, so that'll be the next video, and I'll see you there.